Okay, let's continue. Until now, we covered the Gulf of Mexico area, and now we're gonna move to the Florida and the Caribbean area. Here you can see a really nice looking picture taken by the space shuttle of Florida and the Bahamas part of the Caribbean. During the Cenozoic, Florida experienced a very intensive carbonate formation. It's been in the tropics since the Cretaceous, so it produced a whole lot of carbonate. Um, Through time, however, the carbonate formation moved south a little because around Miami, two big rivers is bringing siliciclastic sediment into the carbonate production zone, and the carbonate producing organisms cannot live in so-called dirty water. When I say dirty, if you have silt and clay-sized siliciclastic sediment that actually clouds up the water, so the carbonate producing organisms cannot live there. When I say clouding up the water, I mean like this. This here is a small creek bringing silt and clay-sized sediment into a bigger creek, and as you can see, it makes the whole area cloudy right there. So no any living thing which needs the sunlight can live in this kind of area. So that's happening in Florida. Most of the carbonate formation today is starting at Key Largo area. The carbonate producing organisms, when they die, they actually break apart into teeny tiny pieces, basically producing carbonate mud. This is an area where you wouldn't want to walk in the water because it's like the clay mud. So when you step in it, it almost sucks you in, so you can hardly pull your feet out. So you don't want to do it. It's absolutely beautiful, white, very, very muddy carbonate mud. This shows the Florida Bay area, and you know that the Florida Bay is right below Everglades. This is here Everglades, and Everglades is a swamp, so most of the sediment is silt or clay sized, and as the weather brings the clay and silt sized sediment in the Florida Bay area, as you can see, the water is extremely cloudy, so there is not really any carbonate formation on that area. Carbonate formation is all on the east side of the Florida Keys, and we do have a well-developed barrier reef here, starting at Key Largo. It's about here. Miami is up here, Key Largo is about here, and it goes all the way down to Key West. And not only there, of course, but as you can see on a slide in a minute, it's the whole Caribbean area. Before I move to that one, I wanted to tell you that in northern Florida, we know about a very famous mammalian Miocene fossils. These guys are mostly horses and camels. So when you walk on the beaches, easily you can find pieces of bones like those on the picture. Obviously, this area was like Chincoteague in Virginia, where you can see all those wild horses romping around. This was the same way in northern Florida in the Miocene. And this here just shows the whole Bahamian region, and that's a cross section of all the carbonates which formed in the Bahamas during the Cenozoic, all the way from the Cretaceous. And as I already mentioned, it goes all the way down in the Caribbean. It's everywhere, carbonates everywhere. And now let's move to the Cordillera region. And this is this region right here. And we're going to talk about the whole region here. Basically, this has been a mobile belt since early Mesozoics. And these are just showing the most important orogenic events. The last one being the Laramide. And as you can see, the Laramide actually goes into the Cenozoic a little bit. And I have already kind of mentioned that you didn't really have to know these names. The Laramide is quite important, and if I didn't ask it, you could always use it as an extra credit. Since the Laramide, the evolution of the Cordillera continued. Some parts of this whole region has experienced large-scale block faulting, extensive volcanisms, vertical uplift and deep erosion depending on which area you're in. Like as the yeah, I have a slides here where I can actually show it to you. As you can see in the earlier part of the Cenozoic, the whole North America, the west side of North America was an oceanic continental plate boundary. But as you can see, like by the later Cenozoic, this transform plate boundary right here basically became the San Andreas Fault as it collided toward the continent, collided into the continent. And as you can see, this part of the mid-oceanic ridge is basically going underneath, which producing um, the Graben faults all around the western part of the country and a lot of volcanoes. And of course, the northern part is still oceanic continental plate boundary, so we have all those volcanoes related to that. And this is just a slide showing the San Andreas Fault. It's right here, you can see it. Actually, this slide, that yellow line shows the San Andreas Fault. So you can see it's pretty, it comes in on land around San Francisco, and you can follow it all the way down to the Gulf of California. So now we're gonna move to eastern North America. So from this area, we're moving to the eastern North America. We already talked about the Gulf of Mexico, Florida, Cordillera, and now we're going to talk about this area right here. So eastern North America has been a passive margin since early Jurassic. I want you to remember that. It's important that you know the western part is an active margin, but the eastern part has been a passive margin since the Atlantic Ocean have gotten wide enough. That just means that we do not really have earthquakes. We don't have big active fault lines. We do have some earthquakes, and they are related to the activation of old fault lines. The most severe earthquake in our area happened August 31st, 1886 in Charleston. This was like almost 8 on the Richter scale, and about 60 people were killed, and most of the buildings were damaged. That's just a picture of some of the damaged buildings. This slide really well shows what has happened here. Remember, at the end of the Permian, Appalachian was as tall as the Himalaya today. But by the end of the Cretaceous, it's completely peneplain. That means it became flat. So all the sediment have eroded away. And since then, during the Cenozoic, actually, we've seen new uplifts, and the rivers are cutting in, and old fault lines getting reactivated. So this is what's happening today. And if you look at the plate tectonics, you kind of can understand what really causes the uplift. Here is North America, right here, right here. And as you can see, the Atlantic Ocean opening up right here, and it pushes North America to the west. But then from the west, it's an oceanic continental plate boundary, so it's moving the whole continent to the east. So that causes that we do get some kind of uplift in the eastern part, and yeah, the rivers, which already kind of established meandering rivers, such as the New River, the James River, and all the other rivers, have to actually cut down to get to the ocean. So we see rejuvenation of these rivers. And as you can see, today's topography of the Appalachian is very distinct. And this slide just shows you the rivers cutting through these uplifted mountains. Now, the Atlantic coastal plains consist of sediments which are derived from the uplifted Appalachian and before, of course. And the sediment mostly brought in by rivers, and the sediments on the coastal plain has has a lot of fossil assemblies. These are mostly sea cows, whales, sharks, fishes, birds, and reptiles. I actually myself took a field trip with my students to the coastal plain in Corey, where one of my students' little boy actually digged out a whale vertebrate. Um, if you do go to places like this and you find some interesting or important fossils, you cannot really keep it because the museum wants them. Um, Finally, all the sediment which went to the ocean made like a like a sediment wedge, and that's about um, 14 kilometer um, in thickness. So it's amazingly a lot of sediment. And this just shows a couple of pieces of the fossil assemblies of this area, mostly shark tooth. Now, there is a very interesting thing which I want you to know about, that in the Eocene, there was a major meteorite impact right here. Right here. And this meteorite impact made a huge big depression in this area, and it seems like that this depression actually shaped all the rivers going into the Chesapeake Bay area today because of this meteorite crater. And this here shows the cross section which scientists have showed by drillings, and you can clearly see the crater and the cataclysm around it. And this here exactly the location of the crater, and obviously all the rivers going that way. It has really influenced the hydrologic system in the whole eastern United States. Most likely cave has been formed. This meteorite warmed up the groundwater, so we have thermal features in a lot of the caves in the Great Valley region, which is like as 81 is going from New York all the way down to Georgia. So this meteorite impact is extremely interesting, and we have a lot of features which you can still see from that meteorite impact. Okay, so now we are at the Cenozoic climate, but I guess I have to stop right here and restart it because I can only record 15 minutes at the time, and I'm already on 13.